Hey, how you doing today? I'm glad you're taking the time to check out this program on air conditioning because I think it contains some darn good information. In this film, we'll take a look at the scientific principles behind automotive air conditioning and see how AMC Jeep components apply them. Once you understand these principles, diagnosis and service will be easier to do. There's only one reason for installing air conditioning in an automobile: passenger comfort. I don't think either one of these guys would argue with us on the value of air conditioning on a scorching hot day. In addition to air conditioning, there are other factors which can help keep the passenger compartment a bit cooler. Light-colored vehicles don't absorb as much heat from the sun as do dark vehicles. Tinted glass filters out many of the sun's heat rays too. But the most effective way to combat heat and humidity in the passenger compartment is to remove them with an air conditioning system. Most automotive systems, which use a recirculation design, remove air from the interior of the vehicle, remove the heat, and return the air to the interior. It's interesting to compare automotive air conditioning to systems used in buildings. Because of the large volume of space that must be cooled in a building, the size and efficiency of the air conditioning system become important factors. Automotive systems are designed to cool a cubic foot of air much quicker than a building system can. This overkill design comes in mighty handy when a car has been sitting in the hot sun all day long. To understand how air conditioning systems remove heat from air, we first have to look at some very basic principles of physics and chemistry. Principle number 1. Heat always travels from hot to cold. Principle number 2. Hot objects have more heat than cold objects of the same mass. Cold is actually a lack of heat. So, to make an object colder, you remove heat. To make it hotter, add heat. Principle number 3. Everything in the universe is matter, which exists in one of 3 forms: solid, liquid, or vapor. You can change an object's form simply by removing or adding heat. Principle number 4. A liquid must absorb heat in order to boil or evaporate. The temperature of the liquid is stabilized at the boiling point. Here, we're boiling water, which boils at 212 degrees Fahrenheit at sea level. If we added additional heat now, the water would only boil more rapidly. Remember, the temperature of the boiling liquid never exceeds the boiling point because heat loss is always equal to heat input. The heat is simply carried away by the gas. In our water example, the gas formed is steam. Principle number 5. To decrease the boiling point of a liquid, decrease the pressure above the liquid surface. To increase the boiling point, increase the pressure. On the left here, we've increased the pressure 16 pounds per square inch. This raised the boiling point of our water to 250 degrees Fahrenheit. On the right, we've dropped the pressure back down to sea level pressure, 14.7 psi. So now we've dropped the boiling point back to 212 degrees. Here's principle number 6. Heat of compression. As a vapor is compressed, the temperature and the pressure of the vapor increase, although no heat has actually been added. This is the principle used for diesel engine ignition. Here's a principle that we're all familiar with. When air loses heat, condensation occurs. Here, the air surrounding the mug is losing its heat to the cold beer. This is why water droplets form on the mug. This is just the opposite of what happens when a liquid is boiled. Here's the last principle we need. Heat is measured in BTUs. A BTU is the quantity of heat required to raise the temperature of 1 pound of water 1 degree Fahrenheit. As shown here, 1 wooden match burned entirely generates approximately 1 BTU. Now, the key ingredient in automotive air conditioning systems is this refrigerant, which is known as R12. Although there are other types of refrigerants available, this is the only one used in automotive systems. Here, we've placed a glass container of R12 on a block of ice chilled to 25 degrees Fahrenheit. Because the boiling point of R12 is minus 21.7 degrees Fahrenheit, the R12 actually boils here. What is happening here is that the R12 is drawing heat from the glass container, and this heat is being carried away by the vapor. Remember that the R12 must come in contact with a good heat conductor in order to boil and remove heat. A glass container is a good conductor, but the styrofoam cup on the right here is not. Note that the R12 in the cup is not boiling because the styrofoam is a poor conductor, and the R12 cannot draw enough heat from the air to boil. Now let's put together an air conditioning system piece by piece. We'll use automotive components, but remember the same theory applies to building air conditioning systems. As we go along, you'll see how the principles we discussed relate to the behavior of R12. First, we need a condenser, which will allow the heat from the interior of the car to be given off to the atmosphere. And we'll need an evaporator, where the interior heat is absorbed by our system. Now we'll join the condenser and the evaporator with tubing. The next component we'll add is the compressor, which will circulate the R12 throughout the system. This is typical of the units used on all AMC and Jeep vehicles equipped with air conditioning. Here, we've added our compressor and placed a restriction in the tubing with pliers. As you can see, we've also added the R12. Now we've added 2 fans and started the compressor. Here, the white arrows represent the R12. In a moment, we'll see how the R12 changes states in the system. The pressure is raised between points A and B because the compressor is pumping more R12 than will pass through the restriction. This is referred to as the system's high side. The liquid R12 in the evaporator absorbs the heat from the interior of the vehicle. As we've seen, the R12 boils as it absorbs the heat. The green arrows represent the resulting low-pressure R12 gas. Then, the R12 gas, containing the heat, is pulled into the compressor. The intake valve opens, and the low-pressure gas is drawn into the compressor by the intake action of the piston as it travels downward. Then, the compression stroke of the compressor increases both the temperature and the pressure of the gas. Remember our heat of compression principle? As you can see, the compressor contains a certain amount of oil. This special oil is important as it lubricates the compressor and circulates throughout the system. The red arrows here represent the R12 gas, which is now a high-pressure gas. This gas is now pumped into the condenser. The temperature of this gas is higher than the temperature of the air blowing around the outside of the condenser. The warmer gas will lose its heat to the cooler air. Therefore, the high-pressure gas condenses to a high-pressure liquid. The blue arrows here represent the high-pressure liquid. This liquid R12 is pumped from the condenser to the restriction in the line. The restriction reduces the pressure on the high-pressure liquid R12, and the R12 becomes a low-pressure liquid, represented by the yellow arrows. This low-pressure liquid enters the evaporator, boils, absorbs heat, and the cycle begins again. Remember that heat is measured in BTUs. Theoretically, the loss of heat from the condenser is equal to the heat gain in the evaporator. On automotive systems, this expansion valve performs the function of the restriction used in our model system. The thermal bulb, which monitors evaporator temperature, is attached to the outlet side of the evaporator. Based on the evaporator temperature, the expansion valve meters the flow of the liquid R12 entering the evaporator. Here's another important component used on AMC Jeep air conditioning systems. This is a receiver dryer, which is located between the condenser and the expansion valve. The receiver dryer, which acts as a reservoir, stores high-pressure liquid R12. Some also contain a desiccant, which removes moisture from the R12. This is the air conditioning thermostat, which controls the temperature of the air in the passenger compartment. The thermostat controls the air temperature by regulating the power to the compressor's magnetic clutch. When more cooling is needed, the thermostat passes electricity to the magnetic clutch, the clutch is engaged, and the compressor begins to pump. Vehicles equipped with air conditioning need larger fans to provide additional cooling. Larger fans, or fans with more blades, create additional noise at high speeds. They also require more drive power. To eliminate these problems, flex fans, like the one shown here, are used on some AMC and Jeep vehicles equipped with air conditioning. The flex feature cuts down on noise by straightening the blades at high speeds. Some vehicles utilize a fan clutch to reduce engine noise. These units feature a fluid coupling, which reacts to heat. As the engine temperature increases, fan slippage is reduced, allowing the fan to provide more cooling. This diagram represents the AMC Jeep air conditioning system. To summarize and recap our discussion of air conditioning theory, we'll add colors indicating high and low pressure R12 gas and liquid. Incidentally, the gauges shown here are external gauges which are discussed in the reference book. As we've seen, the low pressure liquid R12 picks up heat in the evaporator, boils and vaporizes into a low pressure gas, indicated here in green. This gas is drawn into the compressor. The compressor increases the pressure on the gas. So now we have high pressure gas, red, indicated from the compressor to approximately the middle of the condenser. Then the gas gives up heat to the outside air. As a result, the gas is condensed into a high pressure liquid, blue, in the condenser. From the condenser, the high pressure liquid passes through the receiver dryer and on to the expansion valve. Notice, though, that a pocket of high pressure gas always remains in the top of the receiver dryer. The expansion valve's thermal bulb pressure, orange, varies with the evaporator discharge temperature. This pressure controls the metering action of the expansion valve, which reduces pressure on the liquid R12. Next, the low pressure liquid, yellow, enters the evaporator. There it once again boils, absorbs heat, and the cycle begins again. R12 is, as we said earlier, the ideal refrigerant for automotive use. It is the safest agent available that will remain stable and still absorb and give off great quantities of heat. But don't be fooled. R12 must be handled with extreme caution at all times. First, always wear safety glasses when working with R12, as it can cause blindness if it's splashed in the eyes. And never imitate our not-so-smart pal on the right here. That R12 that he's spraying on his hand can cause frostbite in a matter of seconds. This guy's determined to get into trouble. R12 containers should never be exposed to extreme heat like this. An explosion may occur from the resulting increase in pressure. For this reason, R12 should never be stored in an area where it will be subjected to extreme heat. Here's another potential hazard. When R12 vapors contact an open flame, a poisonous gas is formed. This gas, known as phosgene or mustard gas, was a lethal weapon used in World War I. Well, I hope I've helped you to understand air conditioning theory. I'm sure you've noticed that more and more AMC and Jeep buyers are ordering air conditioning on their new vehicles. And this means we're servicing more air conditioning systems each year. The book that accompanies this film contains the step-by-step procedures you'll need to check and service AMC and Jeep air conditioning systems. By the way, additional copies of this handy book are available.